Have you ever wondered what happens to the water after you flush the toilet or wash your hands? It doesn't just disappear. This used water, which we call wastewater, goes on a very important journey to be cleaned so it can be safely returned to our rivers and oceans. It's a bit like a big washing machine for our whole town. Cleaning this water is super important to keep us and our planet healthy. Without this process, our environment would get very dirty and sick, and so would we. It's a hidden world of science and engineering working hard for us every single day. There are some really clever ways we clean wastewater. Imagine big factories full of pipes, tanks, and special machines all working together. One of the most common methods is called the activated sludge process. It's been used for over 100 years. Another amazing way is using something called a membrane bioreactor, which is like a superfine sieve. And for a more natural approach, we can even use special gardens called constructed wetlands. Each of these methods has a special job to do, and they are chosen depending on how much water needs cleaning and where the treatment plant is located. In New Zealand, they take cleaning water very seriously. They use all these different types of systems to protect their beautiful rivers and coastlines. For big cities like Auckland, they need huge, powerful plants to handle all the wastewater from millions of people. But in smaller, more rural communities, they might use a different approach that fits better with the local environment. It's all about finding the right tool for the right job. The engineers who design these systems are like water detectives, figuring out the best way to make dirty water clean again, no matter where it comes from. Choosing the right technology is a big decision for any town or city. They have to think about how clean the water needs to be at the end of the process. They also need to consider how much space they have for the treatment plant, as some systems are much bigger than others. And of course, they have to think about the cost and how much energy the plant will use. It's a massive puzzle with many pieces, but getting it right means we all get to enjoy a cleaner, healthier world. Let's dive in and see how these amazing water cleaning machines actually work. So what exactly is this activated sludge process? It sounds a bit strange, doesn't it? But it's actually a brilliant idea that uses tiny living things to help us out. The sludge is a muddy-looking mixture, and the activated part means it's full of helpful microorganisms like bacteria. These little critters are the heroes of the story. They love to eat all the yucky stuff in the wastewater, turning it into harmless substances. It's a completely natural process, just sped up inside a big treatment plant. The whole system is designed to give these hungry microbes the perfect home to do their job. The process has a few key steps. First, the wastewater flows into a big tank called an aeration tank. Here, air is bubbled through the water, a bit like in a fish tank, but on a much larger scale. This gives the microorganisms lots of oxygen to breathe, keeping them healthy and very, very hungry. As they swim around, they gobble up the pollutants in the water. It's like an all-you-can-eat buffet for bacteria. This stage is crucial because it's where most of the cleaning magic happens, all thanks to our microscopic friends working hard. After the aeration tank, the mixture of water and sludge moves into another tank called a clarifier or a settling tank. Here, everything calms down. There are no more bubbles, so the heavy sludge, full of well-fed bacteria, slowly sinks to the bottom. The clean water stays at the top. This separation is really important. A big arm slowly scrapes the settled sludge from the bottom of the tank. A portion of this sludge, now activated and full of hungry microbes, is sent back to the start to mix with new wastewater, beginning the cycle all over again. This system is fantastic because it's very effective and can handle huge amounts of water, which is why big cities love it. However, it does have some downsides. It needs a lot of space for those big tanks, and it can use quite a bit of energy to pump all that air. Sometimes the sludge doesn't settle very well, which can cause problems for the plant operators. It's a reliable workhorse of the wastewater world, but engineers are always looking for ways to make the process even better, more compact, and more efficient for our planet. Now, let's look at a newer, more high-tech way to clean water, the membrane bioreactor, or MBR for short. Think of it as an upgrade to the activated sludge process. It uses the same friendly bacteria to eat the pollutants, but it has a secret weapon. Instead of a big settling tank, an MBR system uses special filters called membranes. These membranes have microscopic holes in them, so tiny that only pure water molecules can pass through. The bacteria and any other solids are too big to get through, so they are trapped. This clever filtering makes MBR systems amazing at their job. The water that comes out is incredibly clean, often clean enough to be reused for things like watering gardens or industrial processes. Because they don't need those huge settling tanks, MBR plants are much smaller. This is a huge advantage in crowded cities where space is precious. A treatment plant that used to take up the space of a football field can now fit into a much smaller area. This space-saving design is one of the biggest reasons why MBRs are becoming so popular all around the world. On the other end of the spectrum, we have a wonderfully natural solution called constructed wetlands. These are special man-made marshes designed to clean water. Wastewater flows slowly through a bed of gravel and sand, where the roots of wetland plants like reeds and rushes grow. These roots create a perfect home for a whole community of microorganisms. Just like in the big tanks, these microbes break down the pollutants in the water. The plants also help by absorbing some of the nutrients, cleaning the water even more as it trickles through the system. Constructed wetlands are fantastic for smaller communities, or for adding a final polishing step to water from a larger plant. In New Zealand, the Mangere wastewater treatment plant in Auckland uses constructed wetlands to treat its water before it's released. These wetlands have also become a beautiful wildlife sanctuary, providing a home for rare birds. This shows how we can blend nature and technology together. They don't use much energy and are beautiful to look at, but they do need a lot of land, so they aren't suitable for every location. They are a gentle, green way to clean our water. The world of wastewater treatment is changing fast. Scientists and engineers are no longer just thinking about cleaning water. They are now looking at wastewater as a source of valuable resources. It sounds a bit strange, but our wastewater contains things we can actually use. For example, it's full of nutrients like phosphorus and nitrogen. These are the same things that are in the fertilizers farmers use to grow our food. New technologies are being developed to pull these nutrients out of the water so they can be recycled and reused, which is much better than letting them pollute our rivers. Another exciting idea is turning wastewater into energy. The organic matter in sewage contains a lot of energy. At many modern treatment plants, like the one in Christchurch, New Zealand, they capture the biogas that is produced when sludge breaks down. This gas, which is mostly methane, can then be used to generate electricity and heat to help power the treatment plant itself. This is amazing because it reduces the plant's electricity bill and makes it much more sustainable. It's like the plant is recycling its own waste to create its own power. How clever is that? The ultimate goal is to create a circular economy for water. This means we stop thinking of it as something we use once and throw away. Instead, we see it as a precious resource that can be cleaned, recycled, and reused over and over again. This also means making treatment plants as energy efficient as possible. Operators are using smart sensors and artificial intelligence to run their plants more efficiently, only using energy when it's absolutely needed. This saves money and helps fight climate change by reducing the plant's carbon footprint. So, the future of wastewater treatment is incredibly bright. It's moving away from being just a disposal service and becoming a resource recovery factory. By using smarter technologies like membranes, embracing natural systems like wetlands, and finding clever ways to recover energy and nutrients, we are protecting our planet's most precious resource. Every time you turn on the tap, you can think of the incredible journey that water has been on, and the amazing science that makes sure it's clean, safe, and ready to be used again. It's a hidden world that keeps our world running. Follow Ifectony Civil Infrastructure for your engineering smart insights.